Okay, just as a refresher, because I know that we can all use a refresher every once in a while. Let's start at the very, very beginning. At the very beginning, okay? Because it's a very good place to start. You guys don't get that reference, and that's okay. Okay? So here's the very beginning. It does look like a big plus sign. However, that's not really how I mean it right now. Okay? You guys know these go on to infinity, but we'll put the arrows there just to notate that. Okay? What is this thing right here called? The x-axis. It is not the y-axis. That was a good guess. What's this one called? This is the y-axis. Where is the z-axis? Do you remember? Comes out through the paper like this, right? Okay. Yeah. Smarty pants. How are each of these sections called? What are they called? Quadrants. Okay. What quadrant is this right here? 1. What quadrant is this right here? I tricked you. It's 4. Right? So which one's this one? 3. And this one is 2. And what are those called again? Those are called quadrants. Okay? Now, an even more disturbing example, or refresher, is how would I plot the point 2, 3? I know. We're doing it anyways. No. Positive direction on the x-axis 2. Positive direction on the y-axis 3. X-coordinate, y-coordinate. Okay? How would you plot the point -2, -3? -2 in the x direction, -3 in the y direction. I'm hoping I don't have to do any more examples of that. Okay, good. If you do need some more examples of that, you can look in your book. There are 6 examples about how to plot points in your book. Yeah. Okay. So let's come over here. Just do another refresher. How do I graph the line y equals 2x plus 5? What is this called, first of all? Good. The slope. What's this called? Y-intercept. Very good. Okay. So what do I plot first? Do I plot the slope first or the y-intercept first? Y-intercept. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do I go up 5 or down 5? Up 5 because it is positive 5. 1, 2, 3, 4, 5. Do I put a dot there? Do I put a dot on the y-axis? Yeah, that's why it's called a y-intercept, right? Okay. Now that I have that dot, what do I do next? I use the slope, which is a fraction. What's the fraction of the slope? 2 over 1. Now, lest there be any confusion, you actually say the words 2 over 1. So we're going to go up to and over 1, because you just said 2 over 1. Can I go down 2? As long as I go over left 1, right? Down 2 more, over left 1, down 2 more, over left 1. It's better if you go all the way to the edge of the graph so you can get a better picture of the line. But that's a pretty darn good picture right there. How many points are required to make a line? 2, right? Just the 2. Okay? So can you graph a linear function? Yes? All right. That one was pretty well in your wheelhouse. This one maybe, honestly, not so much. Sorry. Thank you. How do you graph the absolute value of x? First of all, I want to remind you that that was one of the parent functions we talked about last year. Remember that? What shape is it? It's a V. Okay? Where does it start? At the origin. So, because if I put in a 0, guess what I get out? A 0, right? What if I put in a 1? What's the absolute value of 1? 1. 2? What's the absolute value of 2? 2. What about 3? 3. That's all, that's all pretty well and good, right? But what about negative 1? What's the absolute value of negative 1? Absolute value of negative 1 is 1. It's like we're saying, how far is 1 from 0? It's a distance. So do we typically have negative distances? No. We're talking about graphing, so we won't have negative distances here. Okay? What about negative 2? 2. What about negative 3? So, just like you said, it is a V. Okay? I didn't do a very good job. You guys will do better. Okay? So, using our transformation rules that we did like 40 times last year, how would I graph this? I mean, we could make a table, right? We could make a table of values and put in a 1 and I get a 6, put in a 2 and I get a 7, and so on like that. But transformation rules says what? I take that V and move it where? Up 5. This 5 is on the outside of the function. That's a vertical change. I move up 5. I know it's still parent function shape because there's no multipliers here. So it's just the same V, this 5 higher than it was before. You remember that? What about that one? Where is this 2? It's on the inside, so it's going to be a horizontal change. But remember, horizontal changes are backwards of what we think. We think this should go left because it's negative, so it actually goes right. So we scoot, there's no multiplier, so it doesn't change shape. So we just take this point and move it over 2 and move every point over 2. So it looks just like that. You okay with that so far? Okay. The next thing we have to talk about has to do with your calculator. Okay? And get it where you can read it. If I happen to be looking at this graph, these two graphs that are on the screen right now, am I looking at this graph in an appropriate window? Appropriate viewing window, I think is what they call it. Or, let me be more specific, a viewing window or a viewing rectangle. Is that an okay viewing window? It is, but how could we see more of the function a little bit better? You remember how to do that? Menu, window, settings. We want to decide where everything goes, right? So what would be a better x minimum value to put into our window? Well, that's a square root function, so where does the square root function begin? At the origin, right? Okay, so if I want to be able to see the origin for sure, what should I choose as my x minimum? Yeah, you're right, not 0. I don't want to choose 0 because then it's going to be in the corner. So what should I choose? Like -1 or -2 or something like that? Is that okay? Is -1 or -2 more correct? No. Neither one of them are more correct. It's fine, right? What about a maximum value for x? You know what a square root function looks like. It's like whoosh, So how far do I need to go over in a window like this? Probably not any more than 10, right? Remember what this means? How is it going to count? How are these little dashes on the axes going to show up? It's going to do auto unless we change it, and unless you really need to change it, just leave it on auto. It usually makes pretty good choices as a dumb calculator. Okay? What about the Y minimum? How low do I want it to go on the Y-axis? Probably same as before, right? I know we said a minute ago it starts at the origin, so maybe -1 or -2. How high do I want it to go? Same thing, okay, 10. So now when I look at it, is that a better picture? You can kind of, all this quadrant 2, 3, and 4 are blocked out. We know there's nothing in those quadrants, so we don't really need to see it, do we? Okay. What if, however, what I put in to look at was this, the cube root of x. Is that an appropriate viewing window for the cube root of x? Yes, ma'am.
Do you have Aubrey Blake?
Yes, I do.
Can I send her to the office for a moment, please?
Yes, I will. Does she have to come?
you.
Do you have to go right now? Okay. Let's just go ahead. Can you wait just a minute? Okay. Is this an appropriate viewing window for this function? No. You didn't break it. It's not broken. We just can't see this as well as we would like to be able to see. Okay? Menu, window. What would be a more appropriate viewing window for this? Well, if you have doubts, menu, window. What if we just did standard? A standard window. Is that a better viewing window? Yeah, already. Don't forget that's there. Zoom standard is there. Okay, that'll just take you -10 to 10 and then like -6.43 something to that. It just makes it nice. What it does is makes the distance between these values the same as the distance between those values. Okay, does that make sense? Okay, go ahead. Okay, we okay so far? Okay, we're still in section 1.1, so I'm just making sure. Okay. Do you know what well, let me just draw you a picture so you know exactly what I'm talking about. If we were talking about a quadratic function, what shape is that? Yeah, it's a parabola, right? No, nobody said that word out loud, but you're all showing me with your hands. That's okay. Okay? So let's just say we're talking about this parabola right here. There's actually two names for this point right here. Can you tell me the two names? Vertex is one of them because it's specifically a parabola, right? But what's another name for that right there? Where is it crossing specifically on the axis? It's the y-intercept. Now, just to remind you, we use y-int to stand for y-intercept. Yes, I know, it's okay. So what are these called? Here and here, x-intercepts. Is there allowed to be more than one x-intercept? Well, gosh, I hope so, because this one has two. Okay, is there allowed to be more than two x-intercepts? Not on a parabola, but is there allowed to be more? Yeah. Do you guys remember from geometry? There's a function that looks like this. How many x-intercepts does it have? Yeah, an infinite amount, right? It crosses the x-intercept right there, and 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 right there. Okay? You okay? Okay. Fair. I'm checking one thing real quick. Hold on just a second. Do you remember which one this one is? Do you remember what your two options are? Sine or cosine? Do you remember that from geometry? Okay, I want somebody to know that before they get here tomorrow. Can you know that? Could you know it right now? Do you have a calculator sitting in front of you right now? Okay, so first thing I want you to do is turn your calculator on. Don't forget about that. Go to your graph. See if you can figure out if it's the sine function or the cosine function. What'd you get? Does yours look like mine? You want me to show you why yours doesn't look like mine? Look here. Yours probably says deg. God bless you. Which stands for what? Degree. What is this one set in? Radians. Okay, radians. That's what we like to graph in when we're talking about sine and cosine. Okay? Now, if yours just says degree, it's probably like a diagonal line this way, right? Okay. Are we okay so far? What are these called again? X-intercepts. Okay. Okay, so are you guys good on section 1.1? All right. Yeah, that's 1.1. We're good with that. Okay, section 1.2. Here, this is what I also should have showed you. Here's where we started. You remember that? I told you it was section 1.1. So I would label that as well along with the date. Okay? So now we're going to section 1.2. So I'm going to label it. I already have the date on the first page, so I know these are together, so I don't really need to put the date again, do I? Okay. What is that? What kind of equation is that? Good guess. It's a linear equation. How do I know it's linear? Because it's got just an x in it, right? Now, I kind of tricked you, okay, by saying what equation it is, but I didn't give any values for a and b. That makes a huge difference, okay? What I also have to make sure to say is that a and b are not 0. Okay? Can I take that back? B is allowed to be 0, A is not. Okay? But you do need to know that A and B are in the real number sets. Okay? A and B are real numbers. A is not 0. Because if A is 0, what kind of equation is that? That's just a constant value, isn't it? Okay? If I tell you 2x plus 5 equals 0, is that what I want to tell you? Let's just say 2x plus 5. No equation, just an expression. What would you do if I said x equals 3? Oh, you'd substitute it in? So you'd say 2 times 3 plus 5, which happens to equal 11, right? Would you agree then that if the equation was 2x plus 5 or y equals 2x plus 5, that 311 would be on that line? Would you agree with that? Okay. What can you tell me about this? How do I want to do this? How about this? No, I'm not going to do it that way. Sorry. You'll be fine. You'll be fine. Take a breath. All right, this is your favorite thing now. What if it said 2x plus 5 equals 12? Ooh, oh, well, you would solve for x? How do you know that? It's pretty much all you can do, right? How would I solve this for x? Subtract 5 from both sides. 2x equals 7. Divide by 2. X equals 7 halves. That's where we will start again tomorrow.